Oh no, homework. That was funny. Stop. Well, you sniffed. Stop being dumb. Stop being dumb. Stop being dumb. Stop. Wait. No. 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 My cube feels terrible right now. My cube feels really bad. My cube feels very bad. This has got to be the easiest TBLL. I would like my grade for my other exam and my tax project. Stop. You sniffed. I am turning in a project. I mean a homework assignment 9 days late. 9 days late. 9 days late. So, watch as I did all that work. Well, it wasn't going to be for nothing because it helps me prepare for my test and for my project, but still. All that work just to get only 10% of my grade for this assignment, which is 2 points. That'd be funny if I just got 2 out of 20 on this. That'd be so funny. Wow. Stop. 1, 5, 7, 9, 16, 18, 23, 26, 27. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh. Hey, look, she changed the. Oh, wait, never mind. The Unit 4 project was still due yesterday, so too bad. It is now time to do lesson 4.2 problems. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Why is there a bunch of 10, 4, 10, 10, 10, 16, all that stuff? That's weird. That's weird. Oh no. And these are going to take probably 5 billion years because it took the professor 5 billion years to post both. To explain the problems in the videos because it took the professor 1 hour and 20 minutes to do it. Okay, I guess that's not that long, but whatever, stop. Oh. So. Oh no! Oh no. I sniffed. Oh, I sniffed. Oh. Number 11 2. 11 2. 11 2. Oh. Why? I had it open already. Eleven two. 11 2. 11 2. Stop. Stop. Oh my gosh. Oh. Oh. Uh-oh. Oh no! Obviously, this is not right. This one is not right. I don't know what 223 is for. Maybe it's for one of these other ones. We'll just... can I please stop clicking the wrong thing? So, we'll just look at this to see which one we need. We need 10-4. This is for 11-2. This is for 11-2. We need to do this. We have quantity sold, average price, monthly advertising expenditures, disposable income per household. So A seems to be just the stuff that we did in chapter 10. Now, violating assumptions of a regression analysis is probably chapter 11. Which of the variables have coefficients that are statistically different from 0 at the 5% significance level? So, that's fun. Which variables would you choose to remove? So, that's going to be fun. Not fun. Not fun at all. Not fun in the slightest.
All right, good morning, everyone. The first problem for this lesson is chapter 11, number
2.
Explore the relationship
Wait! She must have been reading. She had to have been reading the one from chapter 10. Wait a minute.
Number 2. The file PO210 contains a midterm and final.
Oh.
I'll read the right one. Okay, sorry. The owner. Excuse me, I'm having terrible allergy. Yes. 11-2. The owner of the original Italian pizza restaurant observans estimating progression. This is before first off, looking at the assumptions, we're going to do something a little different than we've done before. And second, looking at the individual progressions and determining if there's one that's not significant.
Oh man. So. What the heck just happened? I messed up the solve. That was terrible. Stop. This cube is terrible right now. It was actually feeling fine like a couple of days ago. Now it feels terrible, and I haven't even done any sessions on it. I've just been solving it randomly while I'm doing other stuff. That was funny.
All right, so having said that, we start off by opening up our data analysis toolpack. And
So, what are we doing? Sales. 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 Stop. Regression. Do all the same stuff that we did before.
regression window.
All the same old stuff. Everything's the same. I'm just going to assume it's all the same.
Is just that because it's across a
Uh-oh.
whole range.
Do we need anything else? Maybe not. She did not select anything else additional to the stuff that we've been doing.
Of variables,
So hopefully it's
of data.
Stop. We have to do 9 more problems and then we're done. That's not that many. Stop. You sniffed. Is it quantity sold? It's got to be quantity sold, right? Dang it, I have to look it up. I mean, I have to confirm that it's actually quantity sold that we're looking at right now.
Or it's X four. Let's see how that goes. There are 4 assumptions of regression, and
The Y range is going to be this. The X range is going to be average price, all that stuff. What if it's the outlet number matters? No. Why would that matter? You can now stop. I don't know why I don't know. Oh no, now I have to reselect it. Stop it. Now we have some numbers. We have 0.97, 0.94, 2 to the negative 7, and we have average price, all that. Stop.
normality to X cross data for variance, almost get a constant.
She's talking about stuff. What is she doing wrong? Oh, I think she meant to do it in the same window as before.
Actually, that we could get line fit, guys.
Oh no! Whoa! Hold on a second.
Making sure that we check off standardized residual and normal probability plot. We could get line fit and residual plots, but in a multiple regression that does it for all of the variables individually, so that is pretty much useless.
Wait, so it looks. Did she mean to do the first one? Dang it, not to check standardized residuals and normal probability plots. Dang it. Now I have to redo it. Dang it. Gotta be kidding me. No. Delete. I will delete this workbook. Now I'll have to redo it again. It better have kept all this stuff the same as before. We have this and this. There. Now it should be good. Now it should be good. It gave me a thingy. And there. Oh my. Oh my. That's a lot of stuff. Oh. That's a lot. Huh. Well, now we have more stuff to deal with. Dang it. I am not looking forward to doing the project. That took forever last time I did the project. Although I was able to finish it all in one day, so that's nice. Okay, did we get the same types of numbers? Looks like we did.
All right, so just jumping to the finished sheet so I don't have to type as I talk.
Oh, look at all this stuff we have to do. Oh my gosh. Oh my goodness. Look at all those plots. You've got to be kidding me. Look at this. We have to do this for every single problem. Did I get the same numbers? What? What? She has 3. Average price, monthly advertising expenditures, disposable income. Okay, looks like it's good.
This output here is actually showing the line, the two options that I said that you didn't need. So going back, yours should look like this. Well, not this mess down here, but basically like that, and then you should have one plot this one. In addition, I did those other plots that I said, but the main thing to look at is all it does is it takes one variable at a time. So you can see when we're doing a multiple regression, they need to be considered all at the same time. So none of these are really of any use to us. So moving on to answer the questions in order here. The chart of residuals versus predicted values, which is right here. How did I get that? Well, remember I said that I wanted to get my predicted values and my standard residuals. Well, it also gave me the residuals. So I don't need those, but I do need those standard residuals. So I'm just going to delete that and shift everything left. Delete that and shift everything left. Then I'd select predicted and standard, everything left. Then I'd select predicted and standard, predicted quantity and standardized residuals, and go to insert menu, insert scale.
Oh my. Well, I mean, it's not hard. It's not hard. So is probability output something we don't want? Like, why would we want the probability output? My goodness. How about we move this up here? Shrink. Then we move the standard residuals up here. Stop being stupid. And then shrink it up just a small bit so it fits. There. That wasn't so bad. But now where am I going to put my answers? I guess down here. So
Alright, so that's all I did to get this scatter plot here. And then of course I added
residuals versus predicted. Residuals versus predicted. So, and this, how do you move How do you move those down? Ah,
The
looks terrible. Why? How do you move it down to the bottom?
normal probability plot is here. And the main thing we're looking for is that these dots fall in pretty much a straight line, not some sort of pattern. If it was a big S-shaped pattern going that way, or the other direction with starting low and swinging high and then dropping low and up, or any other sort of a pattern, then there's a problem with normality. There's some handouts in the commentary area for this lesson that show different images of what a normal plot should look like and what violations of it look like. Okay, so that's dealing with normality, so it doesn't really look like there's any violation of normality. When we look at the residuals versus the predicted plot, the expectation is that this zero line here in the middle has about an equal, and this should have actually been standardized. Okay, this one was done with the straight residuals. That's okay. Standardized is better because the standardized residuals, as you can see on this one here, they range between 0 and positive 3 and 0 and negative 3. And if you remember from the empirical rules, 3 standard deviations, or in this case 3 standard residuals, outside of away from 0 is an outlier. Okay, so that's one thing to look at, is are all our values between negative 3 and positive 3, and then are they fairly balanced? It's the same, about the same
Oh,
amount and distance.
uh-oh. We are at 9:07. We're at 9:07.
The same amount and distance. And then are they fairly balanced? The same, about the same amount and distance below as above. Maybe a little bit more above here with these two up high, but in general there's no pattern here. The dots are just randomly scattered. So that's exactly what we want to see, is no sort of pattern. If I saw a U-shaped pattern, or a sideways U, or an upside down U, some sort of curved pattern, that would be really bad. That would be a violation of linearity. If you saw a pattern that was fan-shaped, like starting narrow and going out wide, or starting wide and getting narrower, that's an indication of a violation of constant error variances. So that would be a violation of homoscedasticity. And since we see no pattern here, there's no pattern, so there's no obvious violation of either linearity or homoscedasticity. Okay, so isn't that convenient? You check both of those assumptions on the same chart. And then
Violations of what?
check both linearity or homoscedasticity. Okay?
Normal probability plot indicates that the distribution of the residuals is fairly close to normal. So, right, the chart. All right, I'm just going to answer it word for word. I don't even care at this point. That's funny. Should I write the answers at the top or the bottom? Maybe I should put both of those plots down below instead, so that the answers are more readily visible. So, that was funny. Because what if she's like, oh, where are the answers? Oh, they're down there. Well, I have my charts down here next to the probability thingy. And I'll put my answers up here. Or you know what I could do, actually? I could shrink these even more and try to fit them all up here instead, so that they're all up near the top. That's kind of a weird looking plot. Maybe not. Dang it. Oh, stop. It's gonna look terrible if I shrink it that much. Like, look at this. I don't know, that doesn't look very good, does it? Yeah. Can I fit them up, both up there? Great. It doesn't matter. Stop. I'm still on problem number 1 of 9 for this section. Dang it. B. I don't even care at this point. I'm just going to copy the words. The chart of residuals versus predicted values. Looks good, no pattern. So there is no obvious violations. There's no obvious violations of assumptions. There are no obvious violations of assumptions. Additionally, the normal probability plot indicates that the distribution of the residuals is fairly close to normal. Like, I feel like if I was to change the dimensions of this, it would look different. Dude, like, so hard to fit everything on this. Dude, I might not even be able to fit all my answers right here. That's fun. I'm trying as best I can to fit them on this part. See? Oh, stop. What was B, anyways? Is there evidence of violations of assumptions? C. Which of the variables in this equation have regression coefficients that are statistically different from 0 at the 5% significance level? Oh, I feel like we're going to have to do another test for that. was funny. We're still stuck on problem 1 of 9 of this assignment. So,
Okay, so isn't that convenient? You check both of those assumptions on the same chart. And then, so far we've talked about 3 assumptions, but I said there was 4. The 4th one is only applies to time series analysis, and the idea is that one time period is correlated to the previous time period or time periods, and that's called autocorrelation. And to look for autocorrelation, we would do a test called a Durbin-Watson statistic, and depending on the value of the Durbin-Watson statistic, we would state that there's an issue with autocorrelation. Okay. We'll look at that later on in the school. Okay. So part C then. Which of the variables have significant explanatory power? P-values. So looking at the p-values for the various regression coefficients.
wait, that's all you have to do? All you have to do is look at those p-values. Are you kidding me? So that p-value that is listed means that that's stuff. Oh man.
Advertising expenditure and disposable income per household. Those are really important important values here, and they are all less than 0.05. So they are all significant predictors. So part D, the answer is don't remove any of them. If one of these values had been greater than 0.05, then we would have said that is not a significant predictor, and we would have said it should be removed from the model.
Yeah, that's what we were getting. Okay, so that's very easy. I already kind of knew how to do that. P-values are all low. Did I get the same ones? 0.002, 0.1, negative to -6, and then 0.01. Is that the same as what I got? Yes. So these p-values down here, I'll select them just to show I know these ones. P-values for the coefficients are all less than 0.05. So, wait, let's see what it says here. They're all significantly non-zero at the 5% level. So they are all 0 at the 5% level. D, do not remove any. Don't remove any of them. Okay, this isn't so bad. That's funny. I have now written my answers for the questions. And so save. And is that it for that one? We're finally done with 1 out of 9. Is that it? Wait, let me just double check these. Yep. It's gotta be it.
Okay, the next one is 11.4.
We are now finally done with that. File. Close. And I have to double check every time I download it. 11.4 is going to involve 10.16. So this one, my goodness, why are they all out of order? They're all completely out of order. 10.16 is going to be 11.4. Wow, that's funny. We have maintenance expense, truck, miles driven, age of truck. Yep, that seems to be the correct one. Estimate the multiple regression equation using the given data. Find 95% confidence intervals for the regression coefficients. Oh my gosh, the intervals. Come on, man. Man, why do we have to do a 95% confidence interval? Why can't we just use the p-value that's given in the test? Like the last question.
Trucking company wants to predict the yearly maintenance of extruded information. This file.
All right, so I think I know how to do this. We'll go data analysis. This is going to be maintenance expense. And this is going to be these two, age of truck and miles driven. And, oh, you know, she might tell us to uncheck certain things. So I guess I'll look at that.
You don't need to check off these other ones because we can assess that. All right.
So it's the same one as last time. Same one as checked as last time. So we now have everything here. Again, we have to do we have to see if they violate assumptions again? Like last time or what? I don't think so. It doesn't say that. So, but let's see if she does anyways. Great.
With the simple linear regression, yeah, check those. You don't need to do the charts by hand yourself.
Oh, I see. Stoppy.
Again, looking at the significance overall of the model, it is a significant model. P-value. The p-value for our two predictors here, we see that miles driven is a significant predictor, 6.9 times 10 to the negative 8. However, age of truck, 0.25 is greater than 0.05, so it's not a significant predictor. Then we also were asking.
Hold up. Hold on a second. Dude, what? What on earth, dude? Oh my. Correlation sheet. Oh no. Like violations of assumptions? Why is B for number 4 didn't even ask for that? What the heck? Jeez. Come on, man. Well, we'll see what she says.
Also, we're asking. And I went right for the p-values. That's my natural instinct. They said to use the upper and lower, the confidence interval here, our upper 95%, lower 95%. Here's what I'm getting at with saying they kind of give you the same information. When 0 is contained in your confidence interval, that means that the whole thing could possibly be 0, which would mean that it has no effect. So that's a pretty good indicator that the variable is not a significant predictor. So again, I like the p-value. It's nice and clean and clear. If it's less than 0.05, it stays in. If it's greater than 0.05, it's not significant. So again, we need to do our plot of predicted values and standard residuals.
Do it again. Do it again. Stop. Stop. And also, I don't know. I mean, I feel like the trend line is good, but whatever. Let's stop. And stop and stop and stop and stop and stop. 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 Did I get the same answers? Let's see. Yeah, I did. I think. Residuals. Stop. Stop. Delete. And then do this. To insert the chart. Something predicted versus something or other.
I'll use my standard predictor plot. So here's the normal probability plot. That might be a problem. See how it's wobbling back and forth? If we put a straight line through here, some of these dots would fall below, some would fall slightly above. And then the other thing we see right away with the standard residuals is that there's a definite U shape to them. They do stay within positive 3 and negative 3, so there are no outliers, but definitely something going on here indicating that linearity is being violated because of that curving. And it looks like normality was violated because of this pattern. So there is evidence of heteroscedasticity.
What about the correlation sheet? Residuals versus predicted values.
This U-shaped pattern. The other thing that it asked about is multicollinearity. Actually, the first thing they asked was autocorrelation. Autocorrelation only applies to time series data. This is not time series data, so there would be no issue with autocorrelation. Okay? Like I said, this looks like a violation more of linearity. Although, if you look here, there's a lot of spread between the dots at some places, and then very little spread between them in other spots. So that is why it also is an issue with homoscedasticity. Okay, so violation of homoscedasticity and most definitely linearity. Now, the other thing it asked about was the correlation. It's called multicollinearity. Multicollinearity.
I will type in the answer for B, except for that part. Time to copy stuff. Stop. So, like, why are we even doing this? It doesn't even say that we need to do that in the problem. In the problem, it skips that. It skips that if there's a violation of assumptions. Wait, hold on a second. No. Like, why? Guess what, folks? I'm gonna skip it. I'm gonna skip violations of assumptions because for this question, it doesn't say you need to do that. So guess what? I'm not gonna do it. Oh my gosh. Oh my. Stop. remove the age of truck. Age of truck, because p-value is 0.26, which is more than 0.05. That's all I need to write. Ha 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 ha, stop. Because p-value. Okay. So, I'm done. I'm going to, although maybe I should watch how she does the correlation thing, because it could be relevant to another question. Oh my gosh. But yeah, for 4, they removed the part where it's asking about the violations of key assumptions. For number 4. So
That your prediction variables actually have some sort of relationship, right? And it makes sense that age of truck and miles driven have some sort of correlation, right? I know for a fact that the longer I own my vehicle, the more miles I put on it. So one of the ways that we could assess this would be to calculate the correlation coefficient. We can also do a scatter plot. It's always handy. So age of truck and miles driven, miles is down here. You see there is some sort of relationship with low miles and low age, and high miles and high age. Okay, and then the last thing we could do to check that out would also be the correlation coefficient. These are right, okay, those two variables. There's no reason to suspect autocorrelation. It's not a time series. The normal probability plot shows an S-shaped pattern, which indicates the data is not normal. It's probably sort of skewed to some extent. You see here, I actually added the straight line to that one. You can do that. You don't have to. I think it makes it easier to see, but if you're short on time, like for example on the exam.
Dude, it takes like 1 second to add that line. You just click the plus and then check the trend line thing, and it takes like 1 second. But whatever, stop. I wonder if she's going to remove points because I didn't do all that extra stuff, but the question didn't ask you for all that stuff because I'm reading this version of the textbook that doesn't have it, so I'm going to skip that part. But anyway, stop. So, numero number. Stoppy 5. Do we have to see if there's assumptions of assumptions in assumption? Hey, wow! Look at this! Number 5 is involving 223. .223 is 11.5. Underscore 5. Size of farm and number of farm. The heck? Average size in acres. This is very weird. Is it the number of farms? Like, what is this? This is weird. Average size of a farm. Oh, I get it. This is the year, number of farms, and the size of the farms. Oh, I see. Stoppy, stoppy, stop. Hey, look, the number of farms is decreasing. And the size of the farms is increasing. That's funny. Simple linear regression model.
I got my second shingles shot on Friday, and I was absolutely miserable on Saturday flat. So it's going to be limiter bad value hurt farming. Use my data analysis toolpad, select regression.
Do all the stuff.
Here, it's checked off. Here, it's checked off.
Stuff. The size of the farm is Y. The number of farms, and then you do a thing, and you do a thing. I feel like there's more room here. For once in our lives. Stop. There. It looks to be kind of off from normal, but doesn't look that much off. Stuffing. None of these are asking about violations assumptions. None of them are. None of the questions. So what is B? Sufficient evidence to conclude that the slope parameter is less than 0. Slope parameter. Oh no! Did I need the other option?
Let's check off those other two.
No.
Options as well, like I said, for a simple linear regression. These are the plots you need. Yeah, okay, fine.
Doing it. I have to redo it. Stop. Data analysis of a data analysis in a data what the
For a simple linear regression, these are the plots you need. Yeah, okay, fine.
derp Here we go. Here we go. Here. Number line normal probability. What if we switch these? Because this is the normal, and this is this. This is this. Stop! 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 Number residual plot. Number line fit plot. Like, we don't have to ask about the assumptions for every problem. They're not asking us this. I'm going to ignore the assumptions thing because it's not asked in the problem.
So there's our normal probability plot. Again, that line is fairly straight, even though it kind of bends a little bit, so it might be not quite perfectly linear, but it's not terrible. This is our just straight out plot of the two variables, the size and predicted size. So the red line is the predicted values, and the blue are the actual data points. And as you can see, they fall very close to each other. So it looks like it's pretty linear, maybe a little bit of a curve here. However, our residual plot, we run into a big problem here in terms of this shape here. The question didn't ask us about those things, but again, I just want to give you some practice.
See?
It should look like some sort of mirror, which actually is a way to get the predicted size to be smaller dots, which I know there is, but I'm not sure it's worth wasting my time right now. You would see that the blue line kind of curves, so it looks like it's violet. All right. What they did want us to do is to whether number of farms was a significant predictor of size of farm, and yes, it is 1.18 times 10 to the negative 48, so very, 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 very small probability, essentially zero. So we can say that that is an accurate statement. So we see here 5.6 million farms in 1950, and we're down to 2.2 million in 2008, and the size of the farm started off about 213 acres, and now
That's it? Just look at the p-value again? Is that it?
okay, so that actually answers all of that.
Really? It's just looking at the p-value again? Are you sure? Less than 0? Well, that's not what she did. She just looked at the p-value and said, which would indicate whether it's, that would indicate whether it's sig different from 0, right? Well, I don't care. I'm just going to say p-value. I'm just going to do what she did in the video. I don't care. P-value of 1.18 times 10 to the negative. There's got to be a shortcut for superscript. Insert. What's the superscript shortcut? Although it might not, it might just be here somewhere. thought it was. I thought there was like superscript thing there. Control Shift Plus. Oh, come on. How is it not working? This is dumb. Come on. Come on. Stop. I can't do a superscript here. I need the superscript. Come on. Come on. Come on. Come on. Come on. Superscript. Superscript Excel. This is crap. 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 Okay, I'm just going to do this. E to the negative 48, which is less than 0.05. So it is significant difference 0. Ten. Number 8.